So welcome to another presentation of ArgoCon, which is how to preview and diff your Argo CD deployments. My name is Kostis Kapelonis. I work for Codefresh as a developer advocate. I'm also an Argo CD contributor, and I'm contributing documentation, blog posts, and stuff like this. So if you want to contribute to Argo and you don't want to write any code, come find me and we can talk. I'm also the co-author of the first ever GitOps/Argo CD certification, which you can find there. So what we're going to talk about today is a very specific problem. Let's say you have finished with Argo CD installation, it works, it's secure, it's fine, and you start looking at pull requests. So I'm sitting in my computer, and this is a pull request that is coming, and I need to approve it. I look at the pull request, and it says that replicas will become from 5 to 20. It looks good, I approve it, I merge it, and nothing happens. So the problem is that many companies have actually a hierarchy of different values. So this is an example with customize. You have a base overlay and then different overlays for 2 environments, and each environment has its own regions. And you can do the same thing with Helm. Maybe you have Helm values and hierarchies. So whenever a pull request comes in, you only see the things that changed. But this is not what you want. Essentially, you want to see the whole context of the pull request, like the whole thing, not just the lines that changed. And in most cases, what you want to see is a final rendered manifest. You don't really care about the customized line or the Helm value that changed. You want to see the final manifest. And especially if you're using Helm, and you have lots of templates, at least for me, mentally running Helm in my mind is not a good thing to do. So whenever a pull request comes in, I need to think and understand what Helm would do and try to understand, okay, does this work or not? So this is something I don't want to do at all. So for Helm users, this problem is even more important, trying to understand what exactly is the change. So this is the problem that we're going to talk about today. And we're going to see 4 solutions, the 3 that are not good and the perfect one that I suggest. So the first one, and the most obvious one, is you say, OK, I know that Argo CD has a built-in Diff utility inside the UI. So whenever something changes, either in the manifest or in the cluster, Argo CD will tell you that something is changed, and then you can click on it on the UI and get the actual change. Like all the manifests will be rendered, you will see the final result, you know what will change, and this works, it's OK. I mean, you can do it, but it has several disadvantages. First of all, it means that you have disabled autosync, because if you enable autosync, this diff will not be visible for a long time, and I suggest you enable autosync because this is how you follow GitOps. You always have the guarantee that what is in Git is also in the cluster. But the biggest problem, if you ask me, is that this happens very late in the process. Like everything is committed, everything is pushed, it's in the repository that Argo CD is following. So by that time, if something goes wrong, you don't have many options. I wouldn't suggest to use this as a regular utility. So my recommendation is if you're doing this, maybe it's OK in a production environment where for some reason you don't want autosync enabled, and maybe it's for quick sanity checking that, yes, this is what I want. But for non-production environments, I think this is not a good idea in general. So that was one option. The other option is to use the CLI utility. And actually, I have a great question for you. How many know the Argo CD CLI diff command? How many know the -- local argument? OK, so some people, but not many people. So if you ask me, this is one of the features that is not advertised very well. There is the basic diff command that allows you to see the same thing in the CLI, but the big thing is the -- local argument that allows you to compare what is in the cluster against any file, not in a Git repository, but something that you have locally on your workstation. So while you are testing something, you can create quickly a manifest in your own laptop and then see what are the changes. So this is how it looks. You run it and it tells you what is different, and you are free to select any files, and you get fully support for Helm or Customize or whatever you're using. So if you have this building block, then the obvious thing is to do the same thing that if you have seen Terraform and Atlantis do. You essentially integrate this thing into a pull request. So you have your CI system, run this Argo CD diff automatically, and then you can attach the result in a pull request as a comment. So by the time you see the pull request, you also have a comment on the diff. And this works. This is what Atlantis is actually doing. But it's not a very good idea because you need access to the cluster. Like Argo CD CLI needs access to the cluster in order to create a diff. So this implies that your CI system has access to the Argo CD cluster, which is possible, but sometimes you don't want to do this. One of the advantages of Argo CD is that you can set up Argo CD on its own, on its cluster, and then it's pulling changes from Git without you having access there. So with this way, you need to give access to the Argo CD server, and also maybe you have a strange topology where, let's say, your deployment servers are in China, your CI system runs in the US, so you need your US server to ask the China server, hey, is this the same, or not? So you might have problems with network there. So it works, but it's not the perfect solution. I think it's great while you are developing. So as you are creating manifests, and if you want to test something yourself, you can quickly run it and see, OK, what I'm creating is also what I need. So great, for local testing, but I wouldn't recommend it for any production use. So another popular choice is to pre-render the manifests and get a final view of what they do. So essentially how this works is usually you have your own GitOps repository that has the source information, so your Helm charts or your customized overlays, and then you have a different second Git repository, which might be a completely separate Git repository, or maybe a folder, or maybe a branch, it's not really important, where you have your final manifests. And then you need to set up an automated process, so whenever somebody changes something in the private Git repo, in the first Git repo that has the source, you generate the manifests and commit them. And Argo CD is looking at the second Git repository, not the first one. So this is how it works. I'm a developer. I change my customized overlay or my Helm values. I commit to the first Git repo, and then I wait. There is an automated process that copies and renders the manifests, commits them to the second repo, and then Argo CD is looking at the second repo. So if I do this, now I have the information on the diff on the second repo, so I can look at how the diff is presented on the final rendered manifest. And you might think that this copy process is simple and you can do it with a CI system, but you also need to take into account your workflow. So let's say I open a pull request to the first repo. If I want to see a diff, like a diff on a pull request, I also need a pull request on the second repo. So do I open it myself? No, you should also automate this. And whenever I approve this pull request, I want to approve it on the first repo, and I want also to approve the pull request on the second repo as well. So things are a bit more complex than what they seem. But the end result is great because you use your native Git provider, what they are offering. So this is the same example as before, the Helm chart. And right now, I see the final manifest. It's not a Helm template. I see the final manifest, and I can say, yes, this change is good. I approve it. Let's go. And I don't need to render anything manually in my head. So this works. And actually, there are some companies that are using it. I think Intuit is one of them. You can do it. That's fine. I mean, you solve the initial problem that you present a nice diff to the user. But I don't personally recommend it because it's super complex to set up. You have more moving parts in your deployment process. You introduce your CI process that does this copying and rendering of manifests. So if your CI system is down, now you cannot deploy anymore. And also, if you're in a big company, you need to put some guardrails in place because you need to prevent people from committing to their own repository. Because remember, one of the good Argo practices is you have one GitOps repository for source code and one GitOps repository for manifest. And now you're introducing a third GitOps repository with final render manifest. So if I want to do a change, I need to be certain that I'm doing it on the source Git repo and not the target Git repo. And also, it completely bypasses the support that Argo CD has for customize and Helm. Because you're passing plain manifests, you're not using that support. So I think it's not the perfect way to do it. So you can use it. If you're using it already, that's fine. I'm not against it, but you need a well-disciplined team in order to explain to people how the workflow works, how to onboard new people that they can understand how it works, and also how to prevent wrong commits in wrong repos. And the reason I don't recommend it is because there is an even better option, which is the one I personally recommend, which is you render the manifests on the fly. So how does this work? If you remember, the problem we had with the Argo CD CLI is that it needs access to the cluster in order to create a diff. But if you're following GitOps, you already have the guarantee that what is in the cluster is in the Git repo. So if you want to compare the current state of the cluster, it makes sense to look at what the Git repo is having, because that's the whole reason that you're using GitOps in the first place. So if you want to make a diff on what is coming as a new change and what is already there, you can simply do a git diff on the pull request that is coming versus the current state in the Git repo without any access to the Argo CD cluster. So this is how it works. There is a single GitOps repository that you have, as always. You do your change in your manifest, in your Helm chart or customize overlay, and then there is an automated process that just does the diff between the pull request and what you already have in Git, and you attach the result as a comment in the pull request. So an Argo CD is looking at the same repo. So you are using, again, the CI system to do something, but it's not a point of failure. Like if your CI system is down, you can still deploy and you don't get this nice diff compared to the previous solution. And it's all Git-based. So there is no access needed to the cluster. And then at the end, as a user, I just go to my normal put request in Git, and I have, let's say, the dump Git diff information that only Git knows, and my smart diff that I have created as a comment in my CI system. And as a human, I look at the second one, the smart one. So this is how it looks. This is an example. I'm looking at the pull request, and you can see I have a comment, and this comment has different sections for the environments that I'm about to deploy, and I can see that in this environment, this is the full manifest that will go on that environment, and this is the actual change that will happen with Argo CD. I don't need, again, to bother myself with Helm templates or customize overlays. So is it perfect? Of course not, it's not perfect. The main problem is that you still need to set up this CI process that diffs the manifest. Also, specifically with Helm, there are some corner cases that I'm not going to go into where the diff you get is not the exact same thing that you would get with Helm. So you might miss something. But everything else is an advantage. It only works for Git. You don't need to do any special networking with Argo CD. There is only one Git repository, the one that both humans use and Argo CD is using. And where is the Flux guy? This is not Argo CD specific. It's for any GitOps tool. So even if you're using Flux, you can do the exact same thing. So you can switch from company to company regardless of the tool that they are using. So that's my personal recommendation. It's simple, it's robust, and you should use it. It works with any CI system and with any topology. But as a final closing point, and I think this is pretty important, so far we have been talking about looking at the diff and understanding what has changed. But it's also important to know sometimes what has not changed, and maybe even more important. So in the previous ArgoCon, I had a presentation about a very popular blog post, which is how you organize your GitOps environments and how you promote changes from environment to environment. I'm not going to go into this topic right now. There is a YouTube recording. Go and watch it in a blog post. But essentially there, the answer was that you should use folders for your environments, and you should have a folder for QA, a folder for production, a folder for staging, and then you copy stuff between them. And there was a specific scenario, which I'm showing in the screen. The orange boxes are folders, and the blue boxes are overlays, or maybe Helm values, whatever you prefer. So there is a change that is coming in, and they say to you, this change should go only to staging. So you make the change in the customize overlay only for staging or Helm values, you apply it, it works, everything's perfect. Then 1 week later, they tell you, oh, this change should now go to production. So you go to the production overlay, you do the same change, you approve it, you merge it, and it works. And then you realize that you have the exact same change in 2 overlays, and the obvious thing to think is, okay, why have this duplication? Let's move this change into the parent overlay, or to the parent Helm value. And a lot of people said that this is a very dangerous operation because you will change many overlays and you don't know exactly what was changed, and they are not going to do it, and it's a risk, and this is why they don't agree with how you should organize your environments, and you should not use folders. So I didn't know the answer back then, but I know the answer now. These people were afraid because this is what the diff gives you, like the default diff. You see some changes. There is a line that is being removed from 2 overlays, and there is a line that is added in the base overlay. And this is a change. Like you see this and say, oh, things are changing. What should I do? I don't know exactly what happens. But if you remember, this is the naive diff, the diff that your Git provider is giving you by default. If you follow my approach and you have the smart diff that I explained, here I have pre-rendered the manifests, and nothing has changed. The end result is exactly the same. So I did some refactorings in my manifest, and I know that what Argo CD will see is absolutely nothing. I know that after I commit this change and merge it, Argo CD will do absolutely nothing. So I can merge this commit with 100% safety and no risk at all. And I did this because I looked at the smart diff and not the native diff that my provider is giving me. So for me, this is even more important, not only to know what has changed, but also to know what hasn't changed. This is the same thing. This is a comment attached on the pull request. I have the URL there. Everything I've showed is not theoretical. You can find code that does this. This was a very popular question. How do you do this? You can go and look at it. So these are the solutions that we have seen. The native Git diff is very naive. It's very simple. It doesn't give you enough context on what has changed. Don't use it. Argo CD UI diff, yes, it's fine, but it's very late in the process, and you lose the autosync behavior if you do this. The CLI, the minus local argument, is OK for local experimentation, but I wouldn't use it for production. If you want to pre-render manifest on a second Git repo, yes, you can do it. Companies do it, but I think it's super complex, and it adds many moving parts. And my favorite way, you render manifests on the fly, and you attach them as a comment on the pull request. It's simple to set up. It works for Argo CD and Flux. There is only one Git repo, and it not only tells you what has changed, but also what has not changed. So these are some resources. The first one is a blog post that has what I explained with many more details. I'm including Atlantis there. It was mentioned in the previous presentation as well, which if you are familiar with Terraform, it's doing a similar thing. It has a pull request, and then it attaches comment on the pull request about the Terraform plan. So what we saw here is essentially an improvement on what Atlantis does, because Atlantis has the same issues. It needs access to your Terraform state, to your Terraform CLI, to your Terraform everything. It has the keys to your kingdom, and we don't want to repeat the same mistake with Argo CD. And then the last one is the link to the Argo CD certification that has lots of things also that includes the promotion to environments. And that's it.
We have a few minutes for questions or arguments. Kostis loves arguments. If you want to raise your hand, you want to have an argument?
Yeah, if you have arguments, don't start them here. Maybe you can find me afterwards and tell me, no, you are wrong. I love that way and that way.
Hi, thanks for the presentation. It was really good. I have a question. Can you please give more details about how you actually make the diff between the Argo, what is running actually now in the cluster and what is in the Git?
If you go to this URL, there is actually a GitHub workflow that I use as an example, and it's the full code. It's not something that is, let's say, super usable. I did it for fun. Essentially, there is a checkout step from the pull request that takes the code of the pull request. Then it runs customize, because the example I'm using is running customize, and it does customize build my QA, customize build my production, customize build my something. It saves the result because it's the final rendered manifest. And then it does the exact same thing from the main branch. Because remember, because of GitOps, we know that what is in the main branch is also in the cluster. And there is a final diff between those, and then there is an attachment to the PR. But instead of me explaining, it's open source. You can just click on it and look at the code and see exactly what it does.
Okay.
And GitHub Actions is just an example. You can do it with CircleCI, Codefresh, Jenkins,
Thank you.
GitLab, whatever.
Other questions?
Hi. One of the slides mentioned like one of the outside use cases. So we use Flux and Argo CD in my group. How about for post renderers? Does it show that as well?
I would guess so. Yeah, I don't see any reason why.
Helm lookups?
It's completely
Yeah, post
independent.
renderers after, for let's say like modifying our Helm charts afterwards. Let's say like it doesn't show up in the values file, but we modify the templates.
Yeah, as long as you're doing the full process. Like I think at the end of the day, you're doing a Helm template or you're doing a customize. So as long as you're applying those post-processors on it, then it would work exactly the same.
Yeah, Customize and Helm again are just examples. You can have your own favorite templating tool that just takes something and prepares a manifest. Same thing.
Yeah. Good question. Questions? We have probably time for one more. What else will they learn in the certification, Kostis?
Promotion between environments, I think, is the big thing. And then Argo rollouts. If you're already using Argo CD and you want to know about Argo rollouts, there are examples there as well.
Thank you, Kostis.